In figure 6.39, block 1 of mass M1 is equal to 2 kg and block 2 of mass M2 is equal to 3 kg are connected by a string of negligible mass and are initially held in place. Block 2 is on a frictionless surface tilted at theta is equal to 30 degrees. The coefficient of kinetic friction between block 1 and the horizontal surface is 0.25. And then the pulley has negligible mass and friction. Once they are released, the blocks move. What then is the tension of the string? Okay, so if we take the block off, it will move obviously there, right? So that will be our direction of movement. Okay, and then I want the direction of movements here as our positive direction. So here we will have x positive, and here I also have x positive. As for y positive, I will use upward here for the positive direction. So we will have it like this. And remember, block 2 here is on the frictionless part. So we'll have this one is frictionless. And then block 1 here have a friction, and the mu k here, that will be 0.25. And the first thing that we need to do is to draw free body diagram at block 1 and also at block 2. And the first thing that we need to do is to draw all the forces at block 1. Okay, so the first obvious force that work on block M1 here is its weight, right? So I will have this one here. Let's name this as FW1, force of the weight number 1. But then the surface here also pushing this block up, right? So that will be the normal force. So we will have Fn here. Okay, and then because they are moving there, and that is pulled by this string here or this cable, we have this tension pulling this block there. So we will have this one as T. Okay, and here because we have coefficient of kinetic friction, we have force of friction, which is to the opposite of the direction of movements. Because this moves there, in this part here, we move there, right? And so the friction is to the opposite direction of the movements. So we will have F here. Okay, let's do analysis on block 1 first. So I will have at block 1 here. Okay, and remember that we have force of friction here. Force of friction there is mu k because it is moving, multiplied by the normal force. So we need to find out what is the normal force first, this one here. And because the normal force is on the y direction, let's do analysis on the y direction first. So we will have sigma F is equal to mass times acceleration. This is the Newton's second law. Okay, and because we work on the y direction, we have this one on the y and this one on the y. And because the blocks moves there, that is on the x-axis, we don't have any movement on the y-axis, right? So here we will have this as 0. Good. And the positive force here is Fn. So I'll have Fn. And the negative force is Fw1. Okay, and that will equal to 0. And so we can isolate for Fn here, and that will equal to Fw1. But that Fw1 is M1 times G. Okay, we can plug in the numerical values here. What is M1? 2 kilogram. Okay, and then what is G? 9.8. And so we will have our normal force here. What is it? 2 times 9.8. 2 times 9.8 is 19.6. So I have 19.6. And the unit here will be in Newton. Good. Now let's move on to the x direction. Okay, again, we have the Newton's second law. Sigma F is equal to mass times acceleration. However, this one is on the x part here. And I will simplify the symbol as A here. Okay, now we have Fx, and the positive side we will have T. And then on the negative side, we will have force of the friction minus Ff. Okay, and then we will have mass times acceleration, and the mass of the block is 2 kilogram. So I'll have 2a here. Good. Then we will have T minus Ff, and Ff is mu k times Fn. Okay, let's plug that in. And that will equal to 2a. Or we can move this to the left hand side. So I'll have T minus 2a. And that will equal to mu k times Fn. Right? So let's enter the numerical value. T minus 2a is equal to 0.25 multiplied by Fn. That will be 19.6. 19.6. And so we will have T minus 2a here is equal to this number here, which is 0.25 times 19.6. Okay, I will have 4.9. 4.9. And I think nothing that we can do from here. Let's save this as equation number 1. And let's clean up our slide to do analysis on the second block. Okay, let's clean this up. Okay, now let's do analysis on the second block here. And let's draw all the forces that works on this block here. And obviously it has its weight like this, right? So I will have Fw number 2. But this is not in the x and y coordinates. We can decompose it into vertical and horizontal component. So here I will have this one here, and we will have Fw2 on the y-axis. And here, because this part here is theta, this part here is also theta, right? And if you see it here, Fw2 on the y direction here, here we have a right angle triangle. Fw2 on the y-axis here is the adjacent of the angle, and Fw2 is the hypotenuse. Adjacent and hypotenuse is cosine, right? So I will have Fw2 cosine of theta, right? And because that one is cosine, this one here has to be sine, right? So I have Fw2 comma x, and that will be Fw2 comma x, that will be Fw2 sine of theta. Good. And what other force that works here? I will have the normal force goes there, so we'll have Fn, but this time Fn number 2. And then this rod here pulling this up, right? So we will have T here. Okay, T. But then because this is frictionless, we only care about the x direction, right? Because the normal force is multiplied by coefficient of friction, but we have frictionless here. So on the y-axis, we don't need to care about that. So we need to do Newton's law analysis at the x direction here, sigma fx, and that will equal to the mass times acceleration. Good. And so on the x direction here, we will have Fw2 comma x on the positive direction, and then minus T on the negative direction. And the mass of the block here is m2, so I will have 3, then multiplied by a. Good. And I think we can isolate this, T plus 3a, and we will have Fw2. Okay, and on the x direction, I will have sine of theta, right? And then we'll have T plus 3a, FW2 is mass number 2 multiplied by G and sine of theta. Or we will have this numerical values. T plus 3A is equal to M2, that will be 3. And then G is 9.8. And then sine of theta. Theta is 30 degrees. Good. And now let's plug these numerical values to calculator. So we will have T plus 3A here. That will equal to this number here. What is it? So we will have 3 times 9.8 sine of 30. Okay, and that will be 14.7. 14.7, and that will equal to this. That will be equation number 2. Okay, so now we have 2 equations and 2 variables. We can solve this using linear algebra, but the fastest way to solve this is using calculator, right? So let's solve this using our calculator. Let's set this up as equation solver, which is number 5. And we have 2 variables, which is number 1. Okay, let's plug in the coefficient. So I'll have 1, and then minus 2, and then 4.9. Okay, and then 1, and then 3, and then 14.7. Okay, and the x value here is the tension. So I'll have 8.82. So I'll have T here is 8.82 Newton. And what is the acceleration? We will have this one here, 1.96 meter per squared seconds. And what are the question asking us about? We are asked about the tension in the string, and that will be this one here, 8.82 Newton. And I think that's all for this problem. Thank you for watching. See you in the next video. Bye bye.